Hi, I'm Dr. Incognito. In this video, we're going to talk about finding the inverse of a matrix. So in order to talk about matrix inverses, we should begin by talking about the identity matrix. The 2 by 2 identity matrix, which I'll call I2, is the matrix 1, 0, 0, 1. This has the property that if you multiply this matrix by any other 2 by 2 matrix, A, B, C, D, then you will get A, B, C, D. And even if you multiply in the other order, in general, matrix multiplication is not commutative, but the identity matrix will commute with any matrix. A, B, C, D times the identity will still be A, B, C, D. So the question of inverses is, given a matrix A, B, C, D, does there equal another matrix such that A, B, C, D times that other matrix will give you this identity? So for multiplication, this identity matrix has the analog of the number 1. A times the number 1 is equal to A for any number. So when we talk about the inverse of A times the inverse of A should give us that identity element 1. So in the case of matrices, if this matrix has an inverse, then when we multiply this matrix by its inverse, we should get the identity matrix. And the identity matrix can come in any square size. So I3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. You can make any size identity matrix. It'll be square. It'll have 1s down the main diagonal and 0s everywhere else. It will be square, n by n matrix. So in this video, we're going to compute the inverse of a matrix. And the way we do that is by using reduced row echelon form. If we have here a matrix that's square, then we put next to it the identity matrix of the same size, and then we do row operations, elementary row operations, to carry this to reduced row echelon form of A, and then some other matrix on the other side. And the way the theory goes is that if the reduced row echelon form of A is the identity matrix, then this matrix B will be the inverse of A. And if the reduced row echelon form of A is not the identity matrix, then this matrix A does not have an inverse, in which case A is singular. So if reduced row echelon form of A is not equal to the identity, then A is singular, which means it does not have an inverse. So in our example, the reduced row echelon form of A will be I, and so A will be non-singular. It will have an inverse. So here's the problem that we have, and I'll throw a small twist in there. Suppose that A inverse is equal to 1, 2, 2, negative 1, negative 1, negative 2, 0, 0, 2. Let's find the original matrix A. And basically, the twist is that we have the following property for inverses. If you take the inverse of the inverse, then you get back to the original matrix. So if we're starting with A inverse and we want to find A, then all we really want to do is find the inverse of this matrix. That will be A. So I'll set up my matrix. I called it A inverse, 1, 2, 2, negative 1, negative 1, negative 2, 0, 0, 2, and put the identity next to it, the 3 by 3 identity. And now we'll do the operations necessary to carry the left side here, the left 3 by 3 matrix, to the identity, and this one will end up being the inverse of that one. So I have a leading one here. I'll use that to get to zero out that one. So I'm going to do row 2 plus row 1. So the first row 2 will stay the same. Now row 2 plus row 1, negative 1 plus 1 is 0, negative 1 plus 2 is 1, negative 2 plus 2 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0, and the third row stays the same. And now, since we're looking for reduced row echelon form, I want that to be a 0 above this leading one. So I'm going to do row 1 minus 2 row 2 to 0 out that. And then while we're at it, we want this to be a 1 here. So let's do 1/2 row 3. So row 1 minus 2 row 2 is going to give me 1 minus 0 is 1. 2 minus 2 is 0, 2 minus 0 is 2, 1 minus 2 is negative 1, 0 minus 2 is negative 2, 0 minus 0 is 0, row 2 will stay the same, and 1/2 row 3 makes 0, 0, 1, 0, 0, 1/2. And now the last thing that we have to do, we're almost to row echelon form. This is a leading one. We have to have all zeros in that column, so that needs to become a 0. So we're going to do row 1 minus 2 row 3, and that should do it for us. Row 1 minus 2 row 3. 1 minus 2 of those is 1. 0 minus 2 of those is 0. 2 minus 2 of those is 0. So 1, 0, 0. This one minus 2 of those is negative 1. This one minus 2 of those is negative 2. This one minus 2 of those is negative 1. And rows 2 and 3 stay the same. 0, 1, 0, 1, 1, 0, and 0, 0, 1, 0, 0, 1/2. So this is the identity, and therefore this is the inverse of the original matrix. The original matrix was called A inverse, and so this is A inverse inverse. But again, the inverse of A inverse is